Hi, this is Brynjólfur speaking. I'm going to tell you now a little bit about studies that have been made in Vestmannaeyjar. On the first slide, we see where Vestmannaeyjar are located, close to the southwest shore of Iceland. And we see a little map over the islands. Heimaey is the biggest one, where the people live. And we have Surtsey, Álfsey, and Elliðaey. And we are going to talk about the ecosystems there and the studies that have been made to compare those ecosystems. In all of the islands we have bird colonies and we have areas with no birds, and that's what has been compared. So on down left you see Surtsey, and on next slide we see an aerial photo of Surtsey, which emerged from the sea in the 1960s in an eruption, and then it is of course quite young, only 50 years old or so, but the others are not so old. The other islands, they are all believed to have been created after last ice age. Next slide. We see a drawing of Surtsey, and there you can see the vegetation that has formed because of the seagulls that live there. And in later years, seals have also been colonizing on the little northern spit that is shrinking, as you can see. And but still there is a little ecosystem there. Now in this study that was made, that this picture comes from, or this drawing, they found that the species richness was higher in this little ecosystem on the northern spit than on the ecosystem on the south, which I find interesting. But of course the biomass was higher in the south, in the older ecosystem. Let's take a look at next slide. This is another study that was being made in Surtsey. Here you can see, if we take a look, for instance, on the left graph, you can see the difference between biomass stock inside and outside the seagull colony. And of course you can see the same difference on the sea stock on the right graph. And there the biggest bars on the graph on the right side are, I believe, the same as the numbers on the information card on the left of the slide, where you see sea stock 17 to 27 tons per hectare and soil organic carbon 4 to 10 tons per hectare. The 17 to 27 ton is pretty much and equals older ecosystems in the other island, so it has been developing very fast and because of the seagulls. So let's take a look at next slide. Here we see another study that was done to compare activity of ecosystems in 3 islands, and what was found was that the GPP was equal between the older ecosystem in Surtsey and the ecosystems in Álfsey and Elliðaey, and that's quite interesting, I think. But let's move on and look at next slide. Here we have the last study that I'm going to talk about, and what I find most interesting here is the biggest bars down right, which are from 2 old islands, Heimaey and Elliðaey. The smaller one is from where there are no birds, and the bigger one is from a puffin colony. So the striped area is the soil organic carbon, and the difference between those 2 bars are about 25%, rough calculation and estimation of mine, and that would be the average soil organic carbon storage rate difference in 1550 years. Hope you understood this. but it's better explained in my fact sheet. So next slide. This is the same study, and the graph on the right is telling us that there was an equilibrium in those two ecosystems that we had on the slide that I was talking about on the slide before. Now the black triangles are from the puffin colony and the white from the other colony, and this is the storage rate of soil organic carbon, and the puffin colony is always one step ahead, has a little bit more storage rate, and the equilibrium goes up to the year 1000. After that something changes, or maybe it's just not as developed above as below. Maybe the microorganisms are still working on the carbon stock. I don't know. Maybe Bjarni will explain that to us later. But I find it interesting how this graph looks. The last graph slide comes next. Here we have a correlation between SOC storage rate and SON storage rate, and the slope of the line is about 12. So we have about 12 tons of carbon being stored in the ground for every 1 ton of nitrogen. So the nitrogen has a lot of effects on the carbon storing or storage, and of course in the northern latitudes nitrogen is like a limiting factor for the carbon storage. So scientists have been looking at these islands and the ecosystems to try to see what extra nitrogen does, and try to shed light on possible storage in northern latitudes of carbon in the future, and they are pretty optimistic at the moment. And the last slide is from Maria. She is the artist in the group, and the seals say goodbye. Thank you.